Howdy! Funny enough, out all of the findings inside Balatro's source code, all mostly was interested on how it collects and utilizes otherwise meaningless mouse jitter data as a cheap entropy source for the random numbers generation, rather than using something like a system clock as many other games do. I mean, in programming, it's sort of a common way to use mouse as an entropy, and it's a well-known trick for a while. However, even the authors of a popular PC gamer blog wrote an entire article on this topic based on my previous video. But honestly, it also raises a few genuinely interesting questions. Say, how a mobile port or a controller reads the mouse data? Or is it possible to use a precise mouse macro to get the same seed every run? We're also going to break down probably the most popular Wheel of Fortune tarot card to see how it actually works in the code. And lastly, we will look at Balatro's least erratic decks with some crazy edge case seeds and an RNG bug that literally happens once in 770 billion times. That said, let's start with how exactly the mouse is used in seed generation. So, a function called generate starting seed is all responsible for this. Aside from a special handling of anti-8 and higher, for all the other cases it calls a random string function at the end and passes through a seed argument that consists of a free mouse-related data. First two arguments is an X and Y positions of the mouse, although keep in mind it's not a raw screen coordinates, but a window relative pixels divided by in-game scaling factor, so it's still quite predictable. The third argument is a cursor hover time, and honestly, just looking at the code, I thought it meant the amount of time you spend hovering over the start run button. I mean, it makes sense judging by the code only. However, I've modified the game code to include a debug print statements so I can check the real values behind this data. And apparently that third argument works a bit differently. Inside controller.lua file, we can find a function named setCursorHover. It's in this place where these values are set. And as you can see, cursor hover time is set to gPoint timers point total. And as far as I can tell, it's an accumulator for all the DTs, or delta time values of all the frames in a single game session. It means if you run the game and wait for, say, 1 minute, it will contain a float value of 60. It also gets paused whenever you open in-game menus, so when you click that play button, the menu for resuming and starting a new run appears, thus gPoint timers point total also gets paused. Furthermore, I wanted to check what happens if those three values will be the same all the time. Say, a player will precisely move the mouse cursor and click the play button always at the same moment. And the main question is, will a random string function generate the same seed for every new run or not? So I went in the code and hard-coded a seed argument, and then I started a new run multiple times. Honestly, I was kinda surprised it actually generates the very same seed all the time. Apparently, a random string function is deterministic. What that means is that, in theory, one could actually manipulate a generated seed with a precise mouse movement. Although it's not as easy as it seems, because not only you need a software that will pre-calculate what exact X and Y and time values are required for a specific run seed that you need. In practice, the third value, time, is actually not that predictable. It highly depends on GPU render time, vertical sync, file input-output, CPU schedule, in-game FPS, and many other factors. Oh man, this value drifts a lot, which means that in order to manipulate a seed, cursor hover time would need to match to the last bit of a double. And let me tell you, it's simply not possible. And something tells me that the developer of Balatro knew all of this. That's why the combination of mouse position and a delta time accumulator acts as a perfect cheap hardware entropy. A brilliant solution, if you ask me. Now you may also ask, like, okay, but what about mobile port? What data it uses instead of a mouse pointer? Genuinely, that's a great question. And in order to investigate, I had to download Balatro on my Android device and then unpack the downloaded game to check the actual code of a mobile port. Okay, not gonna lie, I was kinda expecting that the codebase is bit for bit identical to the desktop, at least when it comes to seed generation. Mobile code uses pretty much the same cursor position and the same scaling formula. Generate starting seed function uses the same seed data, and pretty much all of those scripts are the same. And what actually makes difference is that Love2D Engine's mouse get position function returns different results on mobile. It uses a finger data on touch event, so when you touch the screen, that's where your X and Y cursor position is located. And we can even confirm that inside the main Lua script. Here you can find an event called Love Mouse Moved that utilizes a touch data. Of course, I haven't compared the whole code base against desktop version, but apparently Balatro deploys the same code for each platform, which means it uses the same input data, but from a different input source. Okay, now let's take a quick look at the code logic behind one of the most popular tarot cards, the Wheel of Fortune, that has a 1 in 4 chance to add an addition to a random joker. However, some of the players doubt that it really works as described. Well, how the code mythbuster is here. The probability roll happens inside card Lua file. It's the same branch that is responsible for ectoplasm and hex cards, and the condition is defined as follows. G point game point probabilities point normal is set to 1, and self point ability point extra is set to 4 inside tarot cards definition table. And pseudo-random function returns a random float between 0 and 1. That means the overall condition is pseudo-random is less than 0.25, which is exactly 25%, or 1 in 4. However, even when it hits the chance, it then picks an addition, which is another random event. And we can find the code responsible for this inside common events Lua file. The function is called poll addition. As you can see, it has a 50% chance for the foil addition, a 35% chance for hollow, and 15% chance for the polychrome. Thus, answering the question, is it really 1 in 4? Yep, it's confirmed in the code. Although the overall outcome distribution would be something like 75% for a roll miss, 12.5% to get a foil, 8.75% to get holographic, and literally only 3.75% to get the polychrome. Which is why probably it feels less lucky than it seems. Finally, let's take a quick look at one of the most broken seeds the Balatro source code can produce. I mean, I guess we all seen the popular all 52 10 of spades seed, and if you start the run with it, the deck will contain only tens of spades. There is also a well-known every joker is holographic seed, all spectral shop seed, and many other unusual seeds that can be considered broken. But what if I tell you those seeds are not deliberately hard-coded into the game? In reality, that's a side effect or an edge cases of Balatro's random numbers generator. To put it simple, it's a bug that became a feature. In short, there are approximately 2.3 trillion seeds that the game can possibly generate. However, only 35 seeds thus produce a starting erratic deck of 52 identical tens of spades. You might ask how it's possible. Well, a thorough explanation might need another video on the topic, and if you want me to make one, let me know in the comments. But in short, it's a result of Balatro's pseudo-hash function that divides by 0 internally and poisons the erratic RNG stream with none values. Once none is in the stream, every card roll lands on the same alphabetically last index, which is S_T, or the 10 of spades. And 3 of those 35 seeds also turn every joker holographic for the first 9 antis. I mean, what are the odds? Well, basically it's 1 in 770 billion times chance for this bug to happen. Jeez, that's one of those bugs you can't really catch before release. Anyways, I hope you enjoyed the breakdown. Make sure to subscribe to the channel, smash that like button and write a comment. Thanks for watching. I'll see you in the next video.